One vital system in most devices today used to control voltage levels is the voltage regulator. A voltage regulator can be used to step down the input voltage supplied to a particular device or be used to stabilize the output voltage from the device. There's quite a number of voltage regulators which can basically be grouped into two. We have the linear voltage regulators and the switching voltage regulators. Linear voltage regulators use linear non-switching techniques to regulate the output voltage from the power supply. The regulator's resistance varies according to the load and results in a constant output voltage. A well-known linear regulator is the Zener Voltage Regulator, which uses the characteristics of a Zener diode to implement the regulator. Alright, so basically this is going to be a two-part video where first of all I describe how the Zener diode operates, and then in the next I'll explain to you how it's used as a voltage regulator. Let's get into it. Now the Zener diode is a semiconductor device with a single PN junction. The circuit symbol of the Zener diode is shown here, and as you can see it has two terminals, namely the cathode and the anode. Now the anode is the positive terminal of the diode and the cathode is the negative terminal of the diode. The Zener diode, like regular diodes, consists of a silicon PN junction which, when biased in the forward direction, that is, when the anode has a higher potential than the cathode, allows current to pass through like a regular wire. When the voltage is reversed, or when the potential at the cathode is higher than the potential at the anode, the diode is said to be in reverse bias and will behave as an open circuit. A Zener diode in a similar configuration is specifically designed to conduct when the reverse voltage is greater than what we term as the breakdown voltage. Just a side note, most regular diodes also have a breakdown voltage, but the breakdown voltage in a Zener diode is much lower and hence makes it easy to be used as a regulator. More of that later. Hey, I rhymed. If you're finding this video valuable, please click the like button to let YouTube recommend this video to others as well. And also, if you're new to the channel, I make electrical engineering videos like this one, and so be sure to subscribe and hit the bell for notifications so you never miss a video. To help you visualize how the Zener diode works, let's take a look at the IV characteristics curve of the Zener diode. This curve shows how the current in the diode varies with a range of voltages. The horizontal axis shows the voltage difference between the anode and the cathode, and the vertical axis shows the current flowing from the anode to the cathode. A negative voltage on the vertical axis simply means that the voltage at the cathode is higher than the voltage at the anode, and a negative current shows that the current is flowing from the cathode to the anode. As seen here, there are two main regions of operation for the Zener diode, which are the forward and reverse regions. In the forward bias region, we notice that the diode enters a linear region after a particular cutoff voltage. For most commercial diodes, this cutoff voltage is somewhere around 0.7 volts. In the linear region, the diode acts as a short circuit and current varies linearly with voltage, just like Ohm's law predicts. Now things get a bit interesting in the reverse bias region. The diode stops conducting for a range of voltages and acts as an open circuit. But above a threshold, commonly known as the threshold voltage or the breakdown voltage, the Zener diode begins to conduct. This voltage remains almost constant even with large changes in current, as long as the Zener diode's current remains between the breakdown current and its maximum current rating. Now this ability of the Zener diode can be used to regulate or stabilize a voltage source against supply or load variations. The fact that the voltage across the Zener diode in the breakdown region is always constant turns out to be an important feature of the Zener diode, as it can be used in the simplest types of voltage regulators. Click on the end screen to watch part 2 of this video where I explain how a Zener diode is used to build a voltage regulator. Thanks for watching, and I'll see you in the next.